room for another nighttime live video with Demotro. And in today's live video, just to get everyone on the same page, we will be looking at some ways I've noticed recently and some ways I'd like to further test that all of the typical main popular, I suppose, meaning first on the results on search engines, calculators seem to have surprisingly low limits for what they can handle, and many of them give different types of error message, some of them what I would call completely incorrect when they surpass these limits, often at the worst case scenario not being a clear warning that it has surpassed its limit, but just claiming something is an answer. And as we jump into that, I first need to pull open a capture on the screen, and I'd like to note also, I have been having a rainy week in this area, and while it's been raining a bunch, I've been working on some computer-related things, which is testing out some ways to make graphics of some geometric and algebraic things. And these are graphics that I wanted to design because I figured making them myself would give me more control and be a good way to build some skill and just be more unique than using and crediting some other person's representation of any diagrams associated with the topic that those will be in, which will be the next main episode on my combo class channel. So make sure that you are all tuned in to my other channel, the one called Combo Class, to see the grade -3 intro episode I've already put out. And this next upcoming episode that will be coming either I'll say this Sunday, or possibly give or take a day in either direction, but I'll say this Sunday, most likely. And that will be, in my opinion, one of the best, if not maybe the best, under some standards, episode or even video I've ever made. Because in some ways, this is just as interesting of a topic as some of the favorite ones I've covered, and I have upped my game in ways that I accompany my things that I'm describing with visuals, because I can't draw everything on a good old whiteboard. Some types of things that we'll explore much too detailed for them to just get a whiteboard. As much as I love whiteboards, and as much as I love calculators. In fact, there are plenty of calculators I could gather from the darkness, but almost all the ones around here that are little actual calculators like you'd have in school are ones that are broken that I got for a supreme discount, many of them $1 or less, at an old store that had a lot of broken calculators, because I thought they would give a good educational vibe to have them around the classroom. But many of them were unbelievably cheap and didn't work even when I got them, even before they entered the realm of chaos here. So today I will be testing online sorts of calculators that you'd look up on a computer. However, if any of you happen to have other sorts of calculator around, or even just the one on your phone, which will be different on different types and eras of phone, I'm curious, leave a comment either during the live stream or after about what is the breaking point that you can notice, or even just an example of something surpassing the breaking point, and what sort of error message or incorrect thing would you find? Or maybe you have a really, really good calculator and you'll have a much harder time finding such a breaking point. Now, first we better look at a pretty good calculator to start. And first of all, thank you to everybody joining me, and welcome to everyone leaving random thoughts in the comments. I will be checking those here and there. I have it pulled up, but as you know, I get distracted between that as well. And thank you in general to everybody saying hello. And here, and yes, the animations I've made will be, they're not exactly animations that I made myself. I do want to work with more collaborators who can animate better than I plan on developing that skill. But being able to just create 2D images can be useful when I'm editing. And so I figured out a way to create some cool things, and I'm really biting my tongue here to not talk about it because I'm excited about it, so I want to talk about it, but it'll be cooler if it just shows up in the episode. Although I will note that in that episode, there are 2 different types of triangles we've covered, and it's mostly about connections they turn out having. And even if you've met these triangles before, make sure to watch through all of the details in the episode. Now, for now, with our calculator experiment, the one I wanted to start with is one that I usually rely on as one I know is one of the better online calculators. And what a sad state of affairs that when we search on Google online calculator, it is not on the first page. That is sad. That's oh, come on, Google, step your game up. These online calculators I'm about to show you, I have to go to page 2 to show you the example of the better one. Come on. It's not. Is it not even on page 2? Okay, so the Wolfram Alpha calculator is good, and they also, if you're really into math, you might want to get their things, some of which cost money, such as Mathematica, that are even better calculation devices for computers. But even just the free online one is pretty good. So we're gonna do Wolfram Alpha calculator, and then we'll come back to that. And basically, their front page has the calculator because that's one of the main things that's on the site, but there are many other cool things on the site as well. And here's an example of a good calculator. Let's put something really hard for it to calculate. Let's say 999 to the power of 999 to the power of 999. That's a pretty big number. Now, of course, when we talk about big numbers, all these numbers are just tiny grains of sand compared to the types of numbers that get generated with certain functions or hyperoperations or things. So really, it's hard to gauge what's a large or small number. But what we'll see today is that even if we call this a big number, a lot of the other calculators suck. So this number that we'll call big for today, they get a pretty good answer for you on Wolfram Alpha. I don't expect them to write out all the digits of that. That's a lot of digits they would have to write out. So they tell me the input, but they also tell me approximately what it is. Now, the one gripe I have with this here that I would edit is I would say approximately. Like they're not being very clear that that's an approximation. And sometimes the thing is, it can be difficult for computers to know when they're making an approximation. That's something that we'll see obviously come into play with some of the out there wrong answers we're about to see. Is there must be something in play with how they use floating point arithmetic or something that the computer doesn't know when it's rounding something always. It's not sure if at the end stage this is what's supposed to be the exact answer or not. Either way, if they're not extra sure, I would say they should put an about or approximately or something like that. But they do give us some cool ways of describing it. They tell us this is basically a scientific notation. It's like scientific notation and then saying how many digits there are in it. And scientific notation already gives you basically a description of how many digits are in a number. And so when written in base 10. And so here it's sort of like 2 iterations deep. They had to go with that. How many digits are in how many digits is sort of how, like the answer to that is about 2,998 digits. About that many are how many digits are in the amount of digits of the quantity. It's a really big quantity. But even with that, they get some good things. They even tell me the last decimal digits. You can learn these things from modular arithmetic patterns of ways that things exponentiated sometimes always fall into certain patterns on a modular cycle. And if I'm talking about like last 3 digits, that could be phrased as mod 1000. And so we can find patterns often when we're doing exponentiation that it's easier to know the last digits of a number than the first digits a lot of the time. And you can imagine that to be the case. If you were multiplying out 2 numbers, the way a lot of people do multiplication, you'd know the ones place before you know the other side of the place, whatever the largest place of the number is. Also, fun note, 9999999 got a lot more nines at the end of that result. So that's a pretty good calculator. Now, what about all of the ones that somehow fill up the first two? I'm just so disappointed that when I first tested this out, I tested a few of them, and then it was kind of funny enough to me and interesting enough that I was like, I'll do a live stream about this and do the rest of the testing there. But I didn't notice the fact that my favorite one I was going to show wasn't on the front page, and I'm disappointed in Google for that. We're just in society for how many clicks these things got, but I don't know. Whatever. Just make sure to give Wolfram Alpha more clicks. Find it on like the 4th page and click it, and then it'll put it earlier. In any case, there's no problem inherently with these calculators. It's good. You want to make your own calculator website? Great. It would probably help some people who, for some reason, couldn't find the other one, or maybe you can make yours better. But so it's not a problem that there's a ton of different online calculators that all have limitations. But what's sort of funny and sometimes sort of like, whoa, be careful here, is how low all of the limits, apart from Wolfram Alpha, of all these front ones that I tested can handle. And this right here is a pretty good metric for a good main one, not only first one, but in some ways main one we're testing here is this is what comes up when you search online calculator. You're somebody who's like, I want to search what's an equation. If you just Google numbers, sometimes you get a result that's like, sometimes I'll do that a lot of the time just to see if numbers are in some sequence or something, and it'll be like something about selling 8 4x4 wood panels or something, and I'm like, no, those aren't the string of numbers I was talking about. But you don't always get the calculator results if you ask it just to multiply something. So a lot of people, I'm sure, are out there searching online calculator. So this is the first thing they see, the one built into Google. There's a way to also turn it into more of a scientific calculator, I believe, with more buttons. But this is the main one, because this is what the most amount of people who are looking on a web browser are going to see as far as online calculators. So you want to wonder about that last number we did? Oh, I'm not even going to try that. That would probably explode the Google headquarters if I try that last number. If I even just try that one's like little friend, 999 to the power of 999, not even going to do it a third time. Infinity. No, Google, no. It's not infinity. Now, here's the problem, is the only reason they would have infinity built in as an answer is that they do accept some things that are supposed to give infinity as an answer. There must be some things involving sines or cosines or a way of phrasing series on here or things like that that should result in infinity for them to have that encoded in here. So the fact that it's a false positive in a way, because this could have been an accurate result. You don't type this in and go, Google can't handle it. If you're young enough or don't know hardly anything about math and you're just looking at this, you're like, hey, you know almost nothing. You're like 5 years old and you're like, are on a computer for some reason. And you're like, hey, I'm gonna wonder, do the numbers end? What happens if you put a really big number? Here, I just learned exponentiation. Let me try this. Oh, I guess the numbers end. I guess the real numbers are open under exponentiation. And this changes a lot of things. But so the main problem here isn't even that they can't handle it, which to me already is kind of wacky that you type online calculator, Google's like, I got a calculator for you. I can do the job. And they can't even give me a scientific estimation of this. They can't even put in scientific notation of some form the result of this as an estimate. It breaks to infinity. That's a little weird, but the weirder part is that they write infinity. They don't write something like, we'll look at better examples on other ones. Now, honestly, the the greatest possible, what we're hoping for on the after the breaking point on a calculator is for it to say something like overflow error or size error or something that tells you, okay, I surpassed the size. If that's not possible, our next best is going to be, let's hope it just says error of some sort, something with the word error in it. If that doesn't work, next best is, we're getting lower on how best these are, but acceptable, we'll call it, would be undefined, which technically undefined, kind of like infinity, should be an answer to some inputs where, like, I wonder, what do they say for 0 to the 0th power? Do they take a stance on that, or they call it undefined? Oh, they took a stance on it. They're in the 0 to the 0 is 1 camp. Ooh, that's a big move, Google, because while there are many contexts where that's true, just on a calculator with no context given, you should probably say undefined, because there are contexts where 0 makes more sense too. And due to that dichotomy of it breaking some rule or another, to the 0th power should be 1, but 0 to the power of should be 0. That dichotomy makes it something you usually want to call undefined unless you're already talking within a branch of math. And when we have just the calculator app, we shouldn't be really making assumptions about, there's a lot of people who might want to know what's 0 to the 0. And, let's hope they're in one of the contexts where this is an unambiguous answer. And I'm not saying I'm against it. If I had to pick one, it often makes more sense to do 1 than 0. I don't know. I'm not going to take a stance yet. But they both make enough sense that I'm in the camp that prefers if you say undefined out of context. Or actually, I may be using that term wrong. It may be an indeterminate form. Is 0 to 0 an indeterminate form? I'm going to double check that later. Undefined and indeterminate are similar but not identical terms for those sorts of expressions that can crash out algebra. And I think that 0 to the 0 may actually be in the camp called indeterminate, but not undefined. Although they are on the big scale similar. They mean doesn't work in the system the usual way. So there's some notes here. Someone said, pretty cool how Desmos has complex numbers now. I'm not sure if you just mean like doing math with complex numbers or that there's a way to graph them. If there is a way to graph them, I will check that later. That sounds quite cool. But last time I checked graphing with it on the main graph portal, at least, they treated I just like a variable. They were like, here's your slider for setting what I equals, as opposed to being one of the axes. And so some people have some different thoughts about 0 to the 0 in the comments I'm noting here, so feel free to leave your thoughts about that as well. But like I noted, if any of you happen to be around your own calculator, let me know at this point, what does it say for 0 to the 0 or the main test we're doing today, which is a big number to the power of another big number. And if it can handle that, try another layer deep. Now, here, we noted, okay, it really doesn't like 999 to the 999. We're going to come back to this in a minute to see what is the thing it can handle? Like, where is the cutoff? I'm curious, because it's probably some binary number that's really large, or one less than a binary number, that's the cutoff. I mean, one less than a power of 2, which are the numbers that are one less than a power of 2, relate to binary because they max out a certain amount of digit places. And so, like, within a certain amount of digits, the largest number you can go up to is 1 less than a power of 2. So by 1 less than a binary number, I mean 1 less than a number that looks like 1 some amount of O's in binary. So here, we're going to come back to this because first I want to show that some of the other calculators, at least they don't say infinity. So here, we're going to try our new, not that high bar for these calculators to try and pass, is I feel like they can handle scientific notation when they go past that. Like if I just say 10 to the power of, oh, this one doesn't even have power of, but they have reciprocal? That's weird. Okay, this one doesn't even have power of. Okay, That's okay. You skipped our test. Got lucky. We are going to come back to Desmos because I feel like there's a few ways to test it on Desmos with just like numbers or with seeing if there's a way to test it on a graph. So we'll come back to Desmos in a minute. Here is calculator.net. Pretty good name they have grabbed right there. And I suppose I should be showing what pages we're on. So this one's calculator.net. And let's see what happens. First, I was going to see if it can handle scientific notation by going more digits than would fit here, but they can fit a lot of digits in this bar. Still, let's just try 10 to the power of 100 and see if it can do scientific notation. So 10 to the power, what? 10 times, that like made it scientific notation. 10 times 10 to the power of. Okay, 10 times 10 to the power of 100. Yeah, so they can do scientific notation. What do they think about 999 to the power of, where's to the power of? 999. Error. Now here we're at the point where still a pretty low cutoff to be calling yourself calculator.net, I'd say. But error is a lot more acceptable than infinity. Now, out of a smaller amount of testing on this, I do want to not test the exact cutoff, but see, can it do something like that? Okay, it can do that. Can it do that? Nope. So what is about the biggest this one can go to? So 10 to the power of 1,000, error. 10 to the power of 500, error. Oh no, that's 5,000. Error. 10 to the power of 100, 1,000, nope. Got that one. 200. Okay, so it's somewhere around 10 to the power of 300. It's going to break. Maybe 400. Oop. Yeah, so between 10 to the 300 and 10 to the 400, this switches from scientific notation to an error. This is the main thing I mean, half of today's stream is just to roast Google for the fact that their calculator that is the first result says infinity for something like not that big. But apart from that, the main point of this live stream is sort of, it's shockingly low when they just stop trying with the estimates for scientific notation. When they just go to, I can't handle it. So this one we tested about where their cutoff is. Let's see if other ones are similar. And first, let's just go back to this one for a moment to check, can it handle the one that could handle? Can it handle 10 to the 300? Yep, that's a way of writing scientific notation. Can it handle 10 to the 400? That would mean it goes past the other one. Infinity! So, okay. They seem to have a very similar cutoff, is what that tells me, on the big range of possible things they could randomly quit at. Between 10 to the 300 and 10 to the 400 is a smallish slice of that range. So they probably have the same cutoff built into those. And I wonder if Google just like steals this from calculator.net. No, I'm kidding, Google. Don't send any spies. Okay. Under calculator.net, to try a few more, because I saw a few other types of error. Wait, no, this is similar to that one. That's doesn't even have exponents. So if you don't have exponents, you dodged the bullet today. So, meaning you skip being roasted, like this one. But, and again, I'll say, if you're someone who runs a calculator website, and I do mock your calculator website, it's still a good service you're doing. I still respect and commend you for having any sort of calculator website you made. With that said, make your errors say error instead of infinity. So, and now we know that calculator.net didn't have that much trouble with it. It's not like the ability to know whether it was some sort of error or whether it should have gone infinite is something that Google can't figure out. Calculator.net could figure it out at least. So here, none of these have exponentiation. Oh, there's squared only. So that's lame to put a squared and not an... If you put an exponentiation, I can go to the power of 2 or to the power of anything else. Okay, maybe they're trying to avoid this issue. Maybe they know they have an even lower cutoff. So, no, we're not talking about the Social Security Retirement Online Benefits Calculator. Or all of these other types of calculator. No, these are just different types of calculator. I want a normal calculator. I tested other ones. It came up different. I was in a different browser, but it was slightly different for first page when I checked on my own before. So we're going to have to go to page 2 before we come back to Desmos, because I know there's more that do allow you to do exponentiation. So how about this one? Let's see if it's similar. 10 to the 300. Can you do that? You got a scientific notation estimate at least. 10, I mean, in that case, an answer, but we'll call it an estimate, because whether it was an answer, an estimate, even having the scientific notation is a lot better than whatever else. When you see it in the scientific notation form, you sort of assume it's not exactly right down to the exact amount, unless clarified that it is. But here, let's see if they can go further. And if not, what is their error? Infinity, come on. This one's calculatorsoup.com. Why are so many of them saying that? This is really silly. It's weird. Why? Why are they saying infinity? Someone tell me what you think is breaking here. Why is Google... Have they overlooked this? Because I feel like if calculator.net knows it's error and not infinity, then why does Google say infinity? So maybe enough of you have to write emails to Google. Tell them, ask them what's up with those things. Say, this letter is about the issue of large numbers on your main calculator. P.S. Also maybe say 0 to the 0 is indeterminate or undefined, whatever that correct term for that expression is. Unless otherwise stated, or give more details if you want to state the cases in which it equals 1. Anyway, that's some, and we're going to try a few more before we go a little closer at what is that cutoff. Here, this one looks pretty high tech. Maybe, can it go any further? 10 to the power of 300. Oh, whoa, it's trying to show it. Whoa! Okay, this one wins. This one gets second place after Wolfram Alpha. This is web2.0calc.com. Second place to this calculator. That is so cool. It's not even scientific notation. They're like, screw scientific notation. I am a computer. I can write 300 digits. It's on you to count them. So, what about 10 to the... I'm guessing it can do 10 to the 400 because it was pretty good at doing 10 to the 300. No, what? What? Okay, I got to be careful because it's really muddy here because of the rain and the chair sinks in and I have to unlodge it sometimes. What? Why? And it's not even like they're coming from the same source. Infinity's lowercase this time instead of uppercase. Why is it so detailed at 10 to the 300 and not here? Okay, well, I guess this actually might be a better one to test what the cutoff is and see if it's the same for Google. We might not get down to the exact number, but let's see if we can give a guess of what it might be. So, is it over under 350? Under. Over under 325? Under. Over under 3, what's half of 25? We're going to want to go about 12 or 13. I'm going halfway down, which we have to round sometimes one way or the other, because that'll make me test the cases in the minimum amount of times in the range I've left. So now 10 to the 306. Okay, it can do 10 to the 306. Where is this cutoff? 10 to the... I'm thinking it probably relates to a power of 2 around this range. So 10 to the 307 it could do. 10 to the 308. And I can do that. 10 to the 309 infinity. But 10 to the 308 it could do. Okay. So, here's what I'm going to see if we can now get help from Wolfram Alpha again for this. Where, let's see if we can find powers of 2 slightly under... I don't know if it's going to understand this language, but sometimes it's actually pretty good at getting what you mean. Slightly under 10 to the 309. Nah, it didn't get that. Power of 2 closest to 309. I'm not sure if it can do this. Nah, Okay, that might be the closest we come to getting the cutoff. My guess is that it is the number 1 less than a power of 2, also known as a Mersenne number. Like, you know, the new largest prime ever known is of the type Mersenne prime. Well, Mersenne primes are the prime subset of Mersenne numbers, which is a name for just being 1 under a power of 2. Also meaning you are a hyper 11 in binary composed of just a string of the digit 1. And the Mersenne number that is... Or there might be multiple, I guess. Yeah, there's probably going to be multiple of them because 2 is smaller than 10. So there's probably more than 1 power of 2 between 10 to the 308 and 10 to the 309. So, yeah. One of those powers of 2... Well, something's going down in the neighborhood. It's not me, I swear, this time. But the 10 to the 308 to 10 to the 309 range... I suspect that some power of 2 in that range is or the number 1 less than that is the cutoff for the Google calculator, at least. And I didn't fully... Did I even double check that Google has the same cutoff? Let's see if it necessarily does, because we only approximately tested that. Is Google the same, where it can do 309... No, 308, but not 309. Yep. So, something is in common. And the interesting thing is, a lot of them must have limitations of their hardware or of some bigger software that they're on that make them have the same limit without them using the same exact code, because it's the same limit on the one that wrote out the whole long number and the ones that are writing it in scientific notation. Or I should say it's probably the same limit. There's a small chance they cut off at different numbers between 10 to the power of 308 and 10 to the power of 309, admittedly. That small chance exists. But assuming that they're the same, this cutoff... So, okay, first of all, here's what we're going to break it down to. What does this mean? How big is this number? If we have 10 to the first power, that has 2 digits, right? 10 to the second power, that has 3 digits, right? So 10 to the 309th power has 310 digits. That's not that big of a number for Google to call infinity. This isn't even a weird equation. This is in the form that they go through when they call things scientific notation. When they give me answers in scientific notation, they have something built into their program to really, easier than other numbers, want to deal with powers of 10. But even just asking, what is the 310-digit number that is a power of 10? They think is infinity. And that's another reason why it's weird that the other one even used the same language of infinity, but one of them was lowercase infinity that they spelled it. I guess I didn't test 0 to the 0 on all of those. And maybe we'll do that in a minute, or maybe we'll do that another day. We do still have Desmos, which we could have a few ways I could imagine testing this sort of thing on. And looking at some of these comments here, we have a comment that usually the bound is under 2 to the power of 1024. We got that comment from actually two people, All Your Memer Belong to Us and RSG. And here, and we say here, Wade says it's approximately infinity. At least it doesn't say equals infinity. That must have been one of the other calculators. I didn't even notice that. One of the calculators said approximately infinity, because that's a whole nother thing in the mix. That's funny. This one straight up says equals right there on Google. And here someone's noting floating points, or a few people are, and yeah, that's related to the type of arithmetic they use to store large numbers on a lot of stuff, and related to limitations of, for a binary size, because they're presumably using a binary type structure, what numbers you're able to get away with and what numbers you can't define properly. The thing that I don't quite understand, if any of you know more about this particular technological aspect than me, is why doesn't the computer know that it's hitting such an absurd floating point error that it's diverging on a really simple thing? What I don't understand is why it doesn't say error. I can get the reason why it can't express this. It is kind of funny that they use so many powers of 10 and it can't tell me this answer as soon as it gets a little, if they had to put one extra zero at the end, even though that should be easy for a computer to store. And like we can see from Wolfram Alpha that you can get away with so much more. Wolfram Alpha was able to give me estimates for so much bigger than this, for 999 to the 999 to the 999, which is absurdly bigger than this number. And so there are ways to make it work. And Wolfram Alpha is a much smaller company than Google. So as someone interested in math, I feel like Google should invest in whatever Wolfram Alpha has if they want to be, before any other results, their own little thing whenever you search calculator. If you search calculator and they're like, before the results, here's a calculator that we made, they could spend as much money as Wolfram Alpha somehow can, because Google's a million times bigger of a company. So Google should prioritize the calculators more. But I almost think it's some type of oversight, and it's supposed to say error, and something went wrong at some point. So I'm not sure why it goes over there. And Logo2462 is noting that there is a particular pattern of bits in the computer defined as infinity. I guess that does make sense, that if they need infinity encoded in, they need a particular pattern of bits. And so we've ended up there. Now, while I understand that this does give computers a lot of limitations, it remains true that for whatever reason, Wolfram Alpha doesn't say infinity, doesn't even say error. It has an estimate for the amount of digits and the amount of digits of the number. So that is so many times better than this, from a much smaller company, that despite those being limitations, everyone's noting in the comments, that are certainly related, there's some way around it. So there's click on the three dots and pop out to see a bigger version, to pop out if I haven't yet. Are you talking here? Do you mean this thing? Because yeah, this is just showing a little history and they are reiterating it. They're putting a clear old equal sign right there. Not any about equals. It is equal to infinity. So I don't know what other three dots you mean, because that's not three dots, but I don't see what you mean. Oh, you mean more here? Well, this is like more sections of Google. This is like if I want Google Maps and stuff. So like this is their primary calculator. And I'm sure maybe Okay, well, try. If I search Google Calculator, do they give me a... This is what comes up if you search Google Calculator. So I'm going to say that's their primary calculator, because if they make it really hard to find any better calculator they may have, then I'm not counting that as providing the resource of a calculator online. They have an app called Calculator, but I don't know if Google made that or that's just showing up because it's on the Google Play Store. This looks like it's just the Android calculator app that comes on phones. So, as a test, I guess I should try it on my phone. Let me see real quick what my phone says. Does it cut off at the same place? Oh, I have to, yeah. If I turn it sideways, it goes scientific. It says error. So the calculator I have says error. Doesn't say infinity, at least. So there are different levels to this, and so despite all the facts about floating point making things difficult, Google doesn't have to say infinity for that. But so that's why I'm curious. And one more comment that's another possibility. Logo2462 is saying that maybe Google Calculator is just using the functions as defined in JavaScript. And that would make sense that it's a particular programming language due to the fact that so many have the same cutoff. And I know that is a sensible cutoff that will occur a lot. For anyone who didn't notice, when I pointed out that a lot of people think the cutoff's probably right under 2 to the power of 1024, note that 1024 is also a power of 2. So it's 2 to the power of 2 to the power of something. And in fact, that's the type of number that relates to something called Fermat primes, except those come on the other side of it, bigger than 2 to the power of 2 to the power of something. That's a story for another day. But keep leaving whatever thoughts or comments, people who know more about the technology side of these things than I do. But I am curious on any theories on, like, what JavaScript is a good suggestion there, that may be a programming language they all have in common. Now, the difference is, though, if these are using JavaScript, Wolfram Alpha was better, hands down, but a lot of the others said error instead of infinity. So what are those using? The ones that say error instead of infinity. Google's choosing to translate error into infinity or vice versa. Those must be coming from different programs, I imagine. So, is this glitching at all? Yeah, maybe glitching a little. Oh, someone said 3 dots in the live chat. Oh, you're right. I hate that. Why was it on top chat? That's annoying. It was just on, top chat, whatever they call that. I don't even know how they gauge top chat. That's annoying. Now I'm on all chat. And thanks to everyone else leaving your particular notes here. And we have a note. Someone says I should type 50 divided by 40. 50 divided by 40 gives us 1.25. No, 50 divided by 49. For a second, I was like, what? What is that supposed to be? 50 divided by 49 gives us 1, 0, 2, 0, 4, 0, 8, 16, 32. And then it's going to crash at some point, because while this 7 is actually a rounded 6... Wait, why is it a 7 there? It should be a 6... 4, I would imagine, if the pattern continues. Oh, but the 6-4 then gets followed up by a 128 that overflows into that, and if that overflows into that being a 6-5, that's just enough to round up to 7. So that does make sense there. But yeah, it looks like binary. So fractions have some really cool patterns in them. Someday I'm going to make a whole episode about a few of those fractions that look like the natural numbers in a row. Here, as we can see, is one that looks like the powers of 2 in a row. And what about ones that look like things like the Fibonacci sequence in a row? Now, if you want a challenge, can you figure out a way to make more room to make this go 002, 004, 008, 016, because then we'd have more room for a lot more powers of 2 before you started overflowing. So, and there is a fraction that'll do that. So see if you could figure that one out. And here, we also have a note from RSG about how I have made a video related to AI's role in all this. And how AI, at least at the moment, or at least as of a few months ago or half a year ago or so when I made that video, very bad and untrustworthy with math. And one key note from that was not just that it's currently bad, but was that both the programs themselves and the media were claiming it was good at the time it was bad. So that's a warning for the future, because I'm not saying that AI will forever be bad at the same types of math it was bad at when I tested it. I'm saying that if they were calling it good and it was bad then, next time they're still calling it good, don't automatically trust it. Because it did not take that much testing. Watch that episode of mine if you're curious. That's on the Combo Class channel. Didn't take much testing to find all sorts of flaws in that. Now, the difference between AI and a calculator is a calculator that the infinity answer almost feels more AI-like, where they're guessing at stuff. More often, calculators say something like error in cases like that. And in those cases, it's a little different because the AI's biggest flaw isn't when it's wrong, but it's how adamant it is about trying to say that's correct. If it doesn't work for it to be correct, they'll just bend a fact here or there so it looks presentable as correct. They would get a conclusion they want to have in their head based on something you ask them. Maybe you ask them, can you prove this thing? And they have from their notes, oh, this is the route I would take to prove it. And if they're sure it's provable and they think that's the route, they'll just make up facts along the way to get there. And so really don't trust AI computers at this stage. And even forever to a degree, AIs are only as good as the non-AI things that they're copying. And I don't know if there will ever be a time where AIs will be better at everything than the things they're trying to copy, because things change and AIs will need to copy new humans to be up to date with how to think about things and a lot of ways of making discoveries and things. And so they're going to have to keep copying new humans and the writings of humans and such, or maybe copying nature or whatever's going on. And by looking at that and copying that over time, they're only going to be like one step ahead at the most. You're not really going to have a time where AI has filled the whole role, because as soon as society evolves an inch, it's going to have to start recopying that based on what the humans were able to do. And that's from a more skeptical side. AI will also have many uses. There will be ways in which it benefits the world and just changes the world a lot. But there will be pros and cons. A lot of cons are coming up because it's kind of scary in the world that it's easy to make fake videos and stuff so easily that people could make a video of a politician that is just like not something they actually said but completely looks like them saying it. That stuff's kind of scary. They're going to need some laws and regulations about that, and morality is going to have to tie into that. But in general, AI can be useful, but do not trust it. Double check whatever it tells you. So, other thoughts on different examples people are leaving in the comments of types of calculator or computer that they have tested it on, as well as some thoughts about reasons that people believe, some likely theories about the particular point that these calculators are breaking at, and some thoughts about maybe what software and stuff is in there. And I will, in general, check a little bit more on that, but one test I would like to at least run right here is looking at if we can see if it makes sense that it can't handle 2 to the power of 1024 but it can handle 2 to the power of 1023. Yep. So that does seem to be the cutoff, which interestingly is 2 to the power of 10. So that's a very combo between binary and base 10-ish number to cut off on, which makes a lot of sense for a computer to use nowadays. And Wade notes that it does seem like Google doesn't overall just care that much about having their calculator handle more marginal cases and expect most people won't notice. And while that's true, it seems to me that the cutoff's way too small. Of course, there's got to be some point where the calculator says error for any calculator, but it doesn't seem like that big of a number. 10 to the power of 309, that is beyond the capacity. That seems like something that I could imagine showing up in like college homework or something, that's maybe even high school homework, of like, oh, here's a really big thing. What is some trait about it or something? Or maybe that shows up something you need data about that to get your answer or something. I can imagine reasons why a general student or even just person could have a time where they would want to know the answer to something larger than 10 to the power of 309. But it is a really big number at that same time. Compared to like atoms or something, that's a really, really large. I mean, compared to like how many atoms are around us or in, the observable universe and such, this is a really, really big number. But some computers can handle it so well. And another thing other people could test, if you are curious, what is the breaking points of Wolfram Alpha? What is the points about where they start displaying error? Or can you find a point where they start giving answers that you think may be inaccurate in some way? Because no one's perfect, especially not websites. And next, we're going to try on Desmos, because there's a few ways we could try here. So now we have a slightly better idea what to test. This is Desmos's page that's just a scientific calculator, not even the graphs we usually do on Desmos. But here, let's see if it's similar. Can they do 10 to the power of 1023 but not 1024? Undefined. Oh, Desmos has a smaller limit. Desmos, whoa, is this the worst one yet? I mean, just in terms of their limit? Oh man, I didn't want that to be the case. I like Desmos. I've made a lot of cool graphs on them. Yeah, this might be the worst one yet because can't even handle that. Well, and I mean, when I say worst one yet, all the ones that didn't have exponentiation built in would probably crash a lot lower in terms of numbers. But it would take more symbols you'd have to type to crash it. This isn't that many digits to crash it with what they're giving me. Now, if that's lower than the cutoff for Desmos here, what is it? Now, the reason it's worse is because they're probably, instead of using another software that's just common for something else to do this, they're probably using whatever software is built into the capabilities of their graphing stuff. Because I think they started as a graphing calculator before they had this aspect. Maybe not. But I'm guessing it's worse because it's sort of not trying to get these from a graph, but trying to get these in the same way it tries to make its graphs, which would have, a lot lower limitations you'd need to build up to. You don't expect a graph to need something as big here as maybe, something that would show up in algebra. I mean, you could see it on a graph, but less commonly. Okay, so this one is between 10 to the... Wait, no. I did that wrong. It's not the worst one yet. I need to do 2 to the... Okay. Is this one? Okay, good. I was really doubting Desmos. I was trying to have their back, figuring out reasons why it was probably just built on the online calculator. But no, I was accidentally doing 10 to the thing that we calculated. It's 2 to that power. So it actually seems to have the exact same limit. Never mind, right there. And there's some notes here about other exponents and other cool comments. I'm not able to go through all of the comments in detail because there's a bunch on this stream, but definitely keep leaving interesting thoughts, and I will scroll through them when possible throughout this stream and or later. Now, what I want to try here is Desmos' graphing calculator, and I want to go a little beyond what would they break here, because like if I just have a question here, if I just say x equals 10 to the this, oh no wait, it was supposed to be 2 to the that can tell me that in the same way. That's what I meant, like they're using whatever same one is built into here. But is the graph gonna break in other ways if I try and incorporate something bigger? Like what I was wondering is, what if I take something really simple? Like we're gonna say y equals x squared. But now what we're gonna do is we're gonna add 10 to the power we'll do the 2 to the power of 1023 on each side. This should still look like y plus x squared. What happened? Yeah, so something went weird here. You see how this should just be y equals x squared because they both have the exact same thing added. If we subtracted that from both sides of the equation, it's just gone everywhere. But it did not make the graph look the same as y equals x squared. So the actual graphs have lower limitations of where they break. And out of curiosity, just on this test, where's the point where it unbreaks? No, still broken. Still broken. Not broken. So it can't handle that much in this type of thing on the... Whoa, that one... Okay, so here we're at a point where it's half broken. That's pretty cool. Are there other half broken ones? This one's also similarly or maybe the same half broken. To make this easier, I'm going to make this a variable so I can just set it to the same thing. And we're going to need this range to be a little bigger. We're going to go from 1 to 30, and I'm going to make the step just 1 right now because we're doing exponents. Okay, 30 wasn't enough to break it. 1 to 100. Ooh, so yeah, this is interesting how it breaks. So look, again, this, oh, is it already break? Oh, it's already breaking. Is this one broken if we go close enough? Yeah. Whoa, so I guess maybe this one just doesn't even let me zoom in enough maybe to the point where this one looks broken. Or would this one ever look broken if it's just at 1? I was wondering if they're all broken, but it just has a way lower cutoff. But this one doesn't seem to be ever broken. But if I bump it up a bit, it already... No, that one it might be fine with. Or maybe you just have to zoom in a lot. If I bump it up a bit, though, and then I zoom in... Okay, still looking okay. Okay, that's past the point. But some of these points, it's just starting to break. Oop. Let's see how low we can see breaking at. Still seeing breaking. Still seeing breaking. I want to see if the breaking goes forever, and if it just, like, can't even handle y equals x squared if you're zoomed in enough. Sorry to any folks who don't care about this part. We're getting close to what I'm trying to look at. Oh, it won't let me zoom in anymore. I'm as zoomed in as it'll go. That's the maximum. So, this is as zoomed in as I can be. Here, it looks a little jagged. If you look really close, that looks a little jagged. That one looks the tiniest bit jagged. That one looks perfectly smooth. But even at 13, that's interesting. That just having y plus 2 to the 13th power equals x squared plus 2 to the 13th power, those two things aren't doing anything. They're equal on both sides. It jaggedifies it. And if I go up a bit, it can't handle it. So that's an interesting way of not being able to handle it. It had the general shape and then drifted further from the shape. Oh, I'm really zoomed in. And then, okay. And then drifted further from the shape. And if we go far enough, it flattens. It's just like, well, no, maybe it's not flat. Maybe those are just really high up. Because you see how those are there? It goes till there now. Is there going to be another bit up here? Yeah, there's another bit. Oh, it didn't flatten. It's just up. Oh, whoa, it just really glitched. So the high ones didn't flatten it completely. It just like extra glitched it. Look up here. There's going to be another. So even on 100, I bet there's going to be another. We're going to go out to here where this one ends. And seeing all the way at the end here. Okay, I went kind of far. Okay, it's really flattened to this one. Okay, I'll quit soon if it... Oh, no! I'll quit soon if it doesn't end. Okay, okay, never mind. Okay, how about down here? There. Well, now it's all the way back here. Really? Okay, after 70, maybe it made it fully flat. Here, I bet it's way up here. There's going to be some more. Trust me. I know you're doubting, but some more is going to appear up here. Maybe I missed it. Okay, never mind. It's not worth finding it. You can believe me. Some more of it is somewhere, unless it's fully flat at that point for some reason. But that's one type of glitch. Now, I bet it's going to glitch even lower if we put these things related to variables. So another way we could try and glitch it out is instead of adding the same thing to each side, multiply. Here's just like our normal parabola. What? Wait, why is it all... Yeah. Okay, yeah, I guess it was just where I was zoomed. There's a good old parabola. And if we do something that's the same on like a numerator and denominator here maybe. Like if I say this is also times y to the power of 100x. But then we're going to divide it by y to the power of 100x. Whoa, that's a weird glitch. So again, this should just be y equals x squared if it worked fully. But look, why did it work better over there than up there? It got further up on the left side than the right side. And then if we zoom in here, something went wrong here. Whoa, something went dreadfully wrong with the parabola here. Whoa, that's trippy. Okay. What if this is all accurate and we just found some new crazy mathematical property? It turns out things actually get really, really weird in the number line here. No, this is just a glitch, but it's very strange. And do we get a continuation of it anywhere, or does it just end? Maybe just ends. Would it be similar if these were a higher variable? Why is the left side always bigger? That's funny. Whoa. Look at these dancing dots. You see there's a dot there and a dot there. It's kind of hard to tell maybe. I'll zoom in a bit. Or the dots are still tiny. Look at all these little dots. They're like dancing around as I move. Do you see those dots? Hopping. And here, another thing we could try is, although this will test less of a numerical size, what if we just even try and stack up a few variables? Can it handle one more layer of this? To the power of what? No. Well, wait. Here, maybe it changed something, actually. Because we are seeing half of it. But here. Oh, and we also found someone who RSG noted a fraction that gives the Fibonacci sequence. And you did find one of them. See if the next step would be, and I will cover this in an episode someday for those who don't want to do it themselves yet, but the next step would be, can you find other ones that give different amounts of room for each term? because there's sort of a pattern too to which fraction, what denominator can generate that. So what are some other ways that we could do something? We could have a little bit of additive and multiplicative and complex in a few ways without having a huge number. How's it going to handle if here, well, let's use addition to be extra careful so we don't get anything that we mess up the symmetry or anything somehow. Let's add, well, let's see what happens here if I add something similar to what I did before. A little stack of them. Whoa! That's not right. So, because here, you see how this is the same as this. I'm adding the same thing on each side. And this part's y equals x squared. And the only place that it should theoretically get weird if I'm trying to cancel these out from the equation could be, I suppose, times if they equal these. In any case, it made it quite strange. And we have a note that maybe the range of floating point isn't symmetric, noting some other comments here. And that another note is that the curve may have gotten blockier as I increased the exponent on the 2's earlier was due to the numbers being stored as essentially binary scientific notation with limited digits. And yeah, it is interesting to see the different breaking points. Let me know if any of you can test any strange things that you can plug into Desmos that not only break the graph, but break it in a strange way. Another interesting thing is that when I do a lot of the things that I do messing around with terms on graphs, here's just a random one I just made up, that I've probably tested at some point before, it gives me this warning. This plot contains fine detail that has not been fully resolved. So what I'm also wondering is, why don't we get that warning when we're freaking it out with those equations? Something in those equations are balanced enough that it thinks it has the detail, but it threw off the detail. So these are the most interesting glitches to me, when we're sort of like fully tricking the computer. They don't know they're making a mistake. They're not saying error. Here, they're kind of saying error, even when we are seeing it more properly than those other ones. And if we zoom in enough on these, they remove that warning. But I usually find, even at some scales that have the warning, it can be visible, but not always. This one, not as visible once the warning's there. And there's a lot of different ways we could try tests of these. Let me know if you find any that glitch it out in an interesting way. And someone says they would bet Desmos maybe has documentation for these errors. That would be interesting. Let me know if anyone has a link compiling any of the different errors. I know that they nicknamed this fella named Bernard, who shows up in a lot of graphs, and we've met him in multiple different live streams. This fella named Bernard shows up. It's a particular shape that for some reason occurs as a glitch in Desmos recurringly. And here we have a lot of other cool thoughts. Someone noted something to try on the calculators would be 2 to the power of negative something slightly bigger. And Desmos is a somewhat good test here, I think, for that as well, because when we weren't caring about the graph and we just tested something like this, it did give us that same result. Although, like I said, undefined. I'm calling not quite as good as error, but definitely a step up from infinity. And here we're going to try instead, this is a note from Inspirator, that maybe we want to be a little asymmetric, because maybe the floating point isn't precisely there. Ooh, yeah, that's an interesting one. So there you go. The people leaving comments about all this tech stuff, it's very interesting, because a lot of the math stuff that I do and play around with is purely on just like taking notes and reading and looking at numbers in a more abstract way. And so, although I know a bit about why these glitches were occurring on the big scale. I don't know quite as many details as some of the commenters here about values like this that are common to have certain interesting results. In this case, they're calling that 0. And what pattern do we have here? If we go further, it's still 0. But if we go down to negative 1074, interestingly, a bit different than our positive 1023, it is something it can give me an answer for. And I think that is correct, that it's about that size. Is that correct, that it's 3 to the power of, or no, 10 to the power of 324? Well, no, that's a little further from the cutoff than we had before. So yeah, it is a bit asymmetric. So that's interesting. We can actually calculate more of the negative powers than higher powers. To reiterate that, 2 to the power of 1030 doesn't work. 2 to the power of negative 1030 works. So that's pretty neat and pretty odd. And we get, interestingly, you know how 0 has 2 really good friends. One of them is the number 1. They're identity pals, they're neighbors, such good friends. But 0's other best friend, infinity. Oh, they're such good friends. 0 and infinity, I don't know which one's whose imaginary friend. They're both each other's imaginary friend. But they're not actually imaginary numbers, don't get confused. But 0 and infinity are sort of balanced around the number 1 in terms of multiplication. Every number from 0 to 1 you could pair up with a reciprocal that's a number from 1 to infinity. And so, related to why, although 1 divided by infinity we can't just call 0, there is some logic to that, despite it not really working. There's a reason why that's close-ish to true in a slightly more abstract way. And here, it's interesting that those 2 friends show up as our errors. Well, actually here, no, 0 and undefined here. So here our lower error was 0, and our upper error was undefined. What about back on Google? So on Google, if we try the negative 1 here, 2 to the power of, well, remember the positive one, first of all. Infinity. No, Google. And 2 to the power, we'll now try one of those negative ones. Can it do negative 1050? It can. So it can also do more negative for the range of that exponent than positive. Now, remember 2 to the power of negative 1050 is not a big negative number. 2 to this power of negative that power. Well, so first let's get a little smaller. What's 2 to the power of negative 1? That's another way of saying 1/2. And so if we go, and the reason we can imagine that is 2 to the first power, 2. If we go up powers, we're multiplying by 2. If we go down powers, we divide by 2. To get to 2 to the 0th power is 1. And then we divide by 2 again. 2 to the negative first power is 1/2. 2 to the negative second power is 1/4, and etc. So there's actually a really small fraction. So when I say it can go further in the negative, I'm not referring to the number of the result and its sign. I mean, as far as the exponent it can handle here, which multiplicatively does show a bit about the scale. Because if we're seeing, how much smaller of a fraction with a huge denominator, or how much larger of a number that we could treat as a huge numerator in a way, there is some interesting asymmetry with what works there. Because that's something to note. With your computer, you also have to calculate really small fractions. It can break at something like 1 divided by a really big number or 2. But we can't even get there because it breaks at the big number before we can get the reciprocal of that. Anyway, here's what I'm curious about. Does it say 0 for the larger one? Now, 2 to the power of negative 1080. 0. So this one ranges from 0 from one type of error and infinity on the other. And it makes sense because this is a number pretty close to 0, and the other number is a number, pretty close to infinity, compared to some of the numbers we use day to day. But here, that's an interesting range. Some of the others we saw, Desmos had a different sort of range. Now, what about that really detailed one? I don't know. Someone else can try on that really detailed one. That one that gave me all 300 digits. Now, there's a lot of other cool comments here, and there's some cool notes about other symmetries and fun facts and things like that. And while there are people here watching, I do want to remind everyone, I just like to say this once an hour or so, what's coming up soon. Make sure that around Sunday you check my combo class channel, because an episode involving a lot of homemade graphics and a really cool concept will be coming out about then on my combo class channel that I've been working very hard on the past few days. I spent a lot of hours making these graphics because I'm using very low budget tech. I'm copy, pasting, resizing, and sliding things more than like, well, now you hit Command and Shift 7 to make your hexagon or whatever. So that will be coming out. Ironically, it will show me able to program some computer things because I made them work, as opposed to now when I know a little. I haven't investigated quite as deeply as some of the commenters about exactly what point it would hit 0 or what point it would glitch. So that's quite interesting. And another question I have for commenters: can you find any other calculators that have a breaking point larger than that, but smaller than, say, Wolfram Alpha? Or even what is Wolfram Alpha's breaking point as well? And I'm also curious about what error message you get on the breaking point. Does it call it error? Does it call it undefined? Does it call it infinity? Etc. And, I think I should wrap up the live stream soon because it is night out here. I don't want to be loud super late. And it is also very cold out here. It stopped raining, so I get a few days without rain apparently. Which is good because I'll quickly note that my neighborhood floods a lot. And if you go out, the yard does it sometimes. And I was trying to walk to the marina the other day after it rained, and there was this one street that was fully blocked off from cars. I was still able to walk there, but I was had to stop because I would have been wading through like half a foot or maybe a foot of water for like 20 feet or something. It's like on a street. It's like, whoa. So that's going to be happening a bit during the rainy season. You may notice there are less clocks on the wall too, which is that some of those I've put away to protect from the rain. Unfortunately, the ground is still really muddy, so like the chair sinks into these holes and starts skewing at this angle that I often need to recorrect. In any case, I was thinking, but I'll save this for another live stream, about looking at some other funny bad mathematics I've collected, particularly bad proofs I've found online, or very wrong applications of mathematics and things. But we'll save some more of that for another day. And there will be, although I did say this last time, I have been starting to refilm shorts that soon will be coming out on the channel. And this time I'm getting a little stockpile of a few, which is why it might not be till next week before I start releasing them, but I'll have a little stockpile that I've already started. And bonus videos and live streams will come when they make sense. I'm mostly excited for the next main episode on the Combo Class channel, and also excited about a lot of other projects I've been working on. Many are videos for this channel as well. Other ones are related to writing or games or other topics. And I think I'm going to wrap up the live stream about there. Let me know if any of you have any other silly results, like the fact that if we do 99 to the power of 999, they say it's infinity as opposed to an error. But any ones that we didn't discuss, if you find them, leave a comment after the fact. As you probably know, the live streams save as videos. And so, although annoyingly, they go straight to being saved as a video, but I don't think the HD processes right away, and I don't think the chat shows up right away. So even though I need to encourage viewers to watch all of them right away as soon as possible, as, needing to be a businessman behind the channel sometimes, I also I'm morally honest, so I must tell you that sometimes it might be better to rewatch the streams half a day or a day later, because then they have the chat and the HD. Although for live streams it matters a little less if it's HD. So that may not matter on many of them anyway, because they're not as visually oriented as some videos of mine. So, wrapping it up there, thank you all for joining me. Remember that if you do want to support the grade -3 that we have just entered, there is a Patreon or YouTube memberships on this channel. Those are super helpful on helping me have enough time to hire camera people and get props and things like that, and camera gear and etc. So thank you to all of those supporters, who you can find their names in the credits of my combo class episodes, and I will update the descriptions of the videos so that the descriptions have the names soon too, but they're at least in the end credits of my main episodes currently, and you do get some bonus content on there too. Also, for people who like random stuff on this channel, this chair it digs these holes into the mud, and then I have to fully realign it, otherwise it just keeps finding the same hole and jolting back into it. So anyway, I love you all. Thanks so much for watching. I hope you're excited for grade -3, as well as a few correlated projects that I will be releasing throughout the next few grades, such as written works and games and things like that. And there will also be music involved in this grade, ranging from music lessons to possibly releases of music I've made. And all of that stuff will be very fun. I'm excited also here just to have some time to film for a sunny week, so I'm planning on getting some good footage over this next week. And I love all of you. I hope one last note, almost forgot this somehow. Here in America where I live, it is technically a kind of big holiday tomorrow. And it's one called Thanksgiving, which is a kind of weird one. There's a sort of weird history behind it, like, you know, when people move from one place to another, historically, sometimes they take over the land from previous people and don't always, maintain the respect of the previous people. So, sort of weird holiday. Shout out to all the Native Americans who, did help build a lot of the original life here and such. But in any case, Thanksgiving is still something that can be culturally fun if you can get past the somewhat weird aspects of it. Just some of the almost cultural tropes of it, like getting chickens and stuff. Although my family went to the store last minute today, and me and my mom went too late and weren't able to get a chicken. I mean, a turkey is the thing. Now, there are turkeys, actual living turkeys, that roam around the marina sometimes, so No, I'm kidding. I'm not going to hunt a wild turkey. We got a different type of food to cook. You don't need to eat that. But various little traditions can still be a good excuse to get together with your family or whatever. So if you have any family and you're doing any of those things, hope you enjoy it and have a nice little feast. And if you have any family members who are interested in math, show them the most applicable combo class content to their interests. In any case, I will catch you again pretty soon. I probably won't put out I don't know if anything will come out tomorrow. I won't promise any schedule apart from the main episode on the Combo Class channel on Sunday, or if there's for some reason a delay on Monday. And I love you all. Thank you so much for watching. I'll catch you again for some other mathematical learning, or possibly funny analysis of less good mathematics like we covered today here and there as well. And I hope you have a wonderful next few days until the next time I catch you in some content or another. Or even sooner if you watch my old live streams and stuff. There's a lot of them. Okay, bye.